Here is the second half of section 6.2. The book calls these inequalities. I don't know if that's the best term for them. It's when you're trying to find a range of different probabilities. And so you'll see phrases like at least, or no less than, or greater than, or equal to. And we remember the math symbol for greater than or equal to, like that. You might see the phrase more than or greater than, which would just be that symbol. You might see fewer than or less than, which goes the other way. No more than or at most or less than or equal to. Lots of different phrases that mean the same thing. Or sometimes you'll just see exactly or equals or is, which is the equal sign. These four symbols require a different function. The last symbol is the binomial PDF we just discussed. These other four symbols, when you see these phrases or see those symbols, is a different function in the calculator. So we're going to learn that new function now. So to find these inequality probabilities, we use the other function that says binomial CDF. The C stands for cumulative. So binomial CDF is when we see all of these phrases in our description. So it's a little bit different. This time the third number is the maximum value in the range. And so this is going to be a little trickier. I would suggest getting some notebook paper to help. I'll show you a way that helps figure these out using notebook paper. So the calculator, this function, binomial CDF, always calculates the probability of less than or equal to. It always starts from 0. It is pre-programmed. This calculator is only programmed to start from 0 and calculate less than or equal to the number you put in. You have to subtract from 1 anytime you're doing a greater than or equal to. So if you do greater than or equal to probabilities, you have to subtract from 1. And I'll try to explain that as I go. Some students find this pretty straightforward. Some students get really frustrated with this, so take your time and make sure it makes sense before you try your test. Alright, so knowing this, we're going to do some examples. We're going to go nice and slow through these. I'm going to use notebook paper to help me explain what's going on here, and I think it will help make sense to you. I suggest always writing it down. If you feel like you can figure this out in your head, that's fine. I do not suggest trying to make a rule up. Students do that and then they get themselves really confused. So I recommend just writing it down each time to help you understand. So for number 24, again, I pulled these out of the book on page 320. Number 24 says that the sample size is 10, the probability of success is 0.65, but this time it says x is less than 5. So what I'm going to do with my sample size of 10 is I'm going to make the numbers 0 through 10. So this is for number 24. List the numbers 0 through 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Always start with 0 through your sample size. And then we need to think where the cutoff point is. We want all values less than 5. So that cutoff point is there. We want 0, 1, 2, 3, and 4. I could use binomial PDF 5 times, which would give me the right answer, or I can find all 5 at the same time by doing binomial CDF, sample size of 10, probability of success of 0.65, and I want the calculator to calculate 0 through 4, so I'm going to put a 4 there. And that's going to calculate 0 through 4, which is what I want. So hopefully that makes sense. Binomial CDF, 10.65 up to 4, and that will give me my values of less than 5, which is 0 through 4. So binomial, this time CDF, cumulative, 10 in my sample, 0.65 probability of success, up through 4. And that will calculate 0 through 4. So second vars, This time, instead of PDF, we're going to use the next option, CDF. And then sample size, probability, and again what I call the target value. So your answer is 0.0949. Alright, so that might not have made 100% sense, but if we go through it again, hopefully it'll click in. Alright, so let's look at number 25, same approach. Number 25. This time our sample size is 7. So I'm going to list the numbers 0 through 7. Always start with 0 through your sample size. And this time we want x is greater than 3. So greater than 3 goes there. We want 4, 5, 6, and 7. We said that anytime we need a greater than, we have to do 1 minus the other. So we're going to do 1 minus this to get these. So it's going to be 1 minus binomial CDF. Sample size is 7, probability of success is 0.5, and the calculator is going to calculate 0 through 3. So we're going to put a 3 there for 0 through 3. If we subtract that from 1, that's going to give us what we want. So anytime you need the bottom half or the greater than half, you do 1 minus the bottom, because the calculator can only do 0 through whatever number's above the line you draw. So a student that was very successful in this class did this technique. She always drew a line at the cutoff point. She knew that the calculator was going to use that value, so that was the value she always used for x. And if she needed the bottom half, she did 1 minus. If she needed the top half, she just put it in. And that was very helpful for her. I've had other students try to make up rules for this, and they just confuse themselves and confuse others. So I have found this technique of making a list, drawing the cutoff line, and knowing that your calculator goes from 0 to the number right above that line. So hopefully that technique will work for you. I'm going to continue doing that for the other 3 examples as well. So we're going to do 1 minus binomial CDF, 7.5, and 3. So you put 1 minus first in the calculator, just type 1 minus, and then second bars, down to binomial CDF, and then your values, 7.5 and 3. Well, that's weird. Usually it's a crazy decimal. So 1 minus first, and then call your function, and then type in what you need, and then whatever it spits out is your answer. Alright, so this takes a little bit of paper, but I do think it helps visually to make sense of these problems. For some students, this is the hardest part of the course, so really take your time here. Let's look at number 26. Alright, for number 26, we have a sample size of 20. So I'm going to list the numbers 0 through 20. I know this seems a little tedious, but it does help. All the way through 20. 0 through your sample size, 0 through 20. Probability of success is 0.7. We want x to be greater than or equal to 12. Greater than or equal to 12. So our cutoff point, greater than or equal to 12, is between 11 and 12. Because if we're greater than or equal to 12, we're 12, 13, 14, all the way down to 20. So this is what we want. The calculator is going to go to there. So because we want the greater than half or the bottom half, we're going to do 1 minus binomial CDF. We have 20 in our sample, 0.7 chance of success, and we're going to go 0 through 11. And we're going to subtract that part off from 1, and that's going to give us what we want. So anytime we need the larger half, or the upper half, or the greater than half, however you want to think about that, you go 0 through the number above the line. And that number above the line is the number you put in the calculator. So I hope this helps. So 1 minus binomial CDF, 20.7 and 11. And whatever that is, let's see. So you do 1 minus first, 1 minus, then second bars to call the function. Binomial CDF, 20.7, and 11. And whatever you get is your answer. Again, I highly recommend writing down your function exactly as you're going to type it in, so that if you get stuck or you get it wrong and you need to ask me or or look on the computer or whatever, you can kind of see what you've put in to help you out. All right, number 27. This time the sample size is 12. So for number 27, I'm going to list the numbers 0 through 12. And you will have scratch paper for your test, so that you can have plenty of space to write these out. So 0 through 12, the probability of success is 0.35, which right now is not that important. We're looking here, x is less than or equal to 4. Less than or equal to 4. So there's my line. I want 0, 1, 2, 3, or 4. Because I want the less than side, I can just do binomial CDF. My sample size is 12. My probability of success is 0.35. And I'm going to go to the number above the line, which this time is exactly 4. And if you notice, we said that the calculator does less than or equal to, which is exactly what we want. So we just type it in, binomial CDF, 12.35 and 4. And whatever that gives us is our answer. So second bars all the way down, 12.35 and 4, which is 0.5833. Again, be very careful with your rounding and your decimals. The computer will tell you how it wants you to round, and you have to round exactly to that amount because it's a pre-programmed answer. All right, number 28, sample size is 11. So I'm going to list the numbers 0 through 11 for number 28. Eventually you might not need to do the list. You might be able to just kind of make the list in your head and find the cutoff point, but I don't think it hurts to make this list just to help you see what you're looking at. So sample size is 11, so we go 0 through 11. Probability of success doesn't matter right now. X is greater than or equal to 8. Greater than or equal to 8. So we want 8, 9, 10, and 11. So that's where we draw our line. Because we want the greater than side, we're going to have to do 1 minus binomial CDF. Sample size is 11.75 is the probability of success. And remember, the calculator goes to right above the line, which is 7. Whoops. Hopefully this is starting to make sense and be consistent. Again, some students try to make up rules for less than or equal to. It just becomes a mess. They try it every semester and it never works. So we're going to do 1 minus binomial CDF, 11.75 and 7. Type in 1 minus first and then call second bars 11.75 and 7. 0.7133. Whoops. 0.7133. I always do 4 decimal places. I want to say the book does 3. The online homework does 3, but I always do 4. That way, if you need 3, you can just round off that last digit. So whichever way makes more sense to you, just be very careful in your online homework. So that is how we do cumulative functions or inequality functions. It takes a little bit more thought, a little bit more planning of what you're going to type in the calculator to get the result that you want. And I definitely think it helps to make this list and draw your cutoff lines so that you know exactly what you're going to put in the calculator. So same idea in that same application problem about wireless households. And if 25% of all households are wireless only, in a random sample of 20, what is the probability that fewer than 3 are wireless only? So X is strictly less than 3. So you can make your list. I'm just going to go ahead and write it out. It should be binomial CDF. We have a sample size of 20, 25% chance of success. If we want strictly less than 3, then we're going to stop at 2. So binomial CDF, type it on in. You should get 0.0913. Then it says at least 3 are wireless only. That would be greater than or equal to 3. So I'm just do 1 minus binomial CDF. And again, you can make your list, or maybe you can work this out in your head. If we want greater than or equal to 3, then my cutoff point will be again at 2. A and B are kind of opposites of each other. So if you notice, I'm putting in the same function in the calculator. It's just this time I'm subtracting from 1. And you should get 0.9087. So the wording can be a little tricky. You just have to practice on the different phrases and how to write them and what they mean. I always relate it to little kids getting cookies. So if you can have fewer than 3 cookies, what does that mean? Or at least 3 cookies, what does that mean? No more than 5 cookies, what does that mean? So if it kind of helps to relate to food, that's usually what I do. So this says no more than 5. No more than 5. That would be x has to be less than or equal to 5. No more than 5. So I'm going to do binomial CDF. Since it's just less than or equal to, then I just type it in just as I see it. And my cutoff point would be 5. Less than or equal to. No more than 5. So binomial CDF. Target value of 5, and I get 0.6172. Now part D, between 5 and 7 are wireless only, and then it says inclusive. That means including 5 and including 7. That means 5, 6, or 7. There are 2 ways to do this. Some students find whichever way easier or more difficult. Let me make the list 0 through 20 here. So this is 4, 5, 6, 10, all the way to 20. I'll tell you which way students generally prefer, but some of you might find the quicker way a little easier. Some students find the longer way a little bit easier. So I want 5, 6, and 7, just this little chunk of information. The short way, so the quicker way, is to do a binomial CDF up to 7, so up to that highest number 7, and that gives you 0 through 7, and then subtract binomial CDF. You're going to subtract off what you don't want. I don't want up to 4, so I have my 2 cutoff points. So I'm going to subtract off what I do not want. This is kind of like if you're laying down a stencil and you paint over the whole thing and then you peel off the part you don't want, and that leaves you the part you do want. So you do a binomial CDF up to the biggest number in your range, and then minus binomial CDF of 1 less than what you want. So you peel off the bottom part you don't want. That's the fastest way to do this. You can type all of this in at the same time in the calculator by doing second bars, doing a binomial CDF up to 7, and then before you push enter, just push minus, call second bars again, binomial CDF, and you just keep typing. So it's a lot to type in at the same time, but you just put a minus in between them, and you're just done. So that is your answer, 0.4833. I've had students in the past that just confused the heck out of them, and they did not like this at all, even though this is the quicker way to do it. So the long way to do this is to actually do a PDF with 5, a PDF with 6, and a PDF with 7, and add them all together. That is much more tedious, but it makes sense to some students that don't like the whole subtraction thing. They just say 1, 2, 3, just add them all up. So you do a binomial PDF, binomial PDF of 5 plus binomial PDF with 6 plus, this gets a little tedious, binomial PDF with 7. And if you have more than 3, just keep on tacking them on. So you have to add them all up. You can do all of this at one time in the calculator, or you can get 3 answers and add them all separately. So a lot of students like to do the first one, get an answer, 0.2023, hit second enter, type in 6 instead of 5, 0.1686. Second enter, change the 6 to a 7. They'll write down all 3 and then add them all up. And it gives you the same answer, 0.4833. So, a little more tedious, a little more time consuming. It is the long way. However, for some students, doing 3 individual PDFs makes more sense than subtracting off. So whichever way you want to do those betweens, they do require a little bit more thought, but the answer should be 0.4833. So the book explains both techniques, I believe. I think it sticks more with the quick way, but there is a long way to do it if the quick way does not make sense. All right, I'm going to pause there and I'll pick back up in just a minute.